From this figure, we are trying to understand what is happening if we have three kind of fibers. One is the multimode step index fiber, another is the multimode graded index fiber, and we have single mode step index fiber. So here we have multimode means the radius is quite high, and we have step index variation like this one. The input pulse will be the same for all the three. For multimode, we have different modes inside the fiber, and because of that, the output pulse will have lower peak power, as well as we have very high pulse duration. So pulse duration will be very high compared to the input pulse duration, right? For multimode graded index fiber, the radius is comparatively higher than the step index fiber, but only variation is the refractive index. Okay, here the refractive index is not showing any step, rather it is changing gradually, right? So what happens because of this gradual change in refractive index, there will be some lens mechanism or focusing arrangement inside the fiber. So the light will travel from this point, and it is moving in different directions because it is a multimode. So it is forming the multimode, but all the modes ultimately will meet at certain point on the axis again because of this focusing arrangement due to the graded index profile. Because of that, the amplitude will amplitude power, the peak power will fall. Definitely it will fall, but not that much, right? As that occurred for multimode step index fibers. At the same time, the duration of the pulse, output pulse, will be larger compared to the input, but compared to step index fiber, the dispersion or the pulse broadening is much smaller. So uh, this is how, or this is why we use this graded index fiber for communication system, and that will actually decrease the dispersion effect. Now if we consider the single mode step index fiber, this radius becomes very small, okay, and it will contain only single mode. There is no chance of other modes, so the pulse width will be almost same as that of the input pulse, but there may be some change in the output peak power, okay, due to some other losses mechanism. The peak power may change, may be smaller, but the pulse duration remains same, right? So actually you can see that the or these three type of uh, fibers, we have 20 megahertz kilometer, 1 gigahertz kilometer, and 100 gigahertz kilometer bandwidth for multi-mode step index fiber, multi-mode graded index fiber, and single mode step index fiber. So as you can see, since there is no intermodal dispersion, the bandwidth becomes highest for single mode step index fiber. Consider a numerical problem. A multimode graded index fiber exhibits total pulse broadening of 1 microsecond over a distance of 15 km. Estimate the maximum possible bandwidth on the link assuming no ISI. Second question is the pulse dispersion per unit length we have to determine. And third question, the bandwidth length product for the fiber. So as we discussed that the bandwidth BT is nearly equal to 1 by twice tau. Tau is given, so it becomes 5 megahertz. This is the bandwidth. The dispersion, we can calculate it in this way, that 0.1 into 10 to the power minus 6 divided by 15, because distance is the 15. Distance is the 15, so 6.67 nanosecond per kilometer. This is the dispersion. Now the bandwidth length product is the B opt or 5 megahertz multiplied by the length of the fiber, that is 15 kilometer, that is 75 megahertz kilometer. This is the bandwidth length product for this fiber. So it's very simple.